Good afternoon, everyone. So today is the 7th day of the Swachhata Pakhwada that we are observing in Niger campus. And today we are going to do an audit of the electricity consumption in Niger campus. So how much electricity we consume every day in campus, and what is the source, from where we are getting, and then what is the transmission and distribution losses of electricity in our campus, and how do we manage, like, the technical things, although I cannot tell all those things because I am not competent enough to understand those languages. So what are the financial implications of the electricity consumption in Niger, and whether we can minimize or we can minimize the consumption and save some energy. So that would be the point of discussion today. And with us we have Mr. Amit Kumar Paningrahi, who is also the scientific officer in the who are managing the electricity supply in campus. So he has prepared a very good PowerPoint presentation, very detailed presentation, in fact I would say. So I really thank Mr. Amit Kumar Paningrahi from in the beginning. Then I welcome all other participants who have joined with us. Today, Mr. Chandrasekhar Mahapatra will be the co-host of the meeting. So with this, I now invite Mr. Amit Kumar Paningrahi to start his presentation. So it's over to you, Amit. Yeah.
Thank you, sir. Good afternoon, all. So, as Harish told, in the next 1 hour, we will discuss from where Niger is getting the electricity, how it is distributed, and its consumption. And in the last, we will discuss some of the measures, how we will save the energy. So, before going to that, I am just sharing my presentation. So, electricity supply, distribution, consumption, and its financial application, and energy saving measures at Niger. So what we will discuss in the next few slides. So these are why, first of all, why we need energy saving. Then from where Niger is getting its electrical supply. Then after getting electrical supply, how it is distributed in our campus. And then the electricity consumption data of Niger, that is the financial implication. And what is the emergency load of Niger, and energy saving, one way of energy saving by power factor correction, and then the general ways of energy saving. Then we'll see some photos of the electrical and electronic waste, what we are generating in Niger. So first we come to why we need energy saving. As we know that till date, around 70% of the world energy requirement are fulfilled by the fossil fuel only. The fossil fuel, it is the we know it is the non-renewable source of energy, which is not abundant in nature, which can be replenished at the same, cannot be replenished in the same way that what we are using. So we are using we are trying to use the non-conventional energy sources much, but till now only 28% of the energy requirement we are fulfilling through non-renewable energy sources. Sorry, renewable energy sources. So the one way of generating energy is, the easiest way of generating energy is only saving. So if you take a data, if we can save 5 units of electrical energy, that is equivalent to generation of the 7 units of the electrical energy. Because in India, especially in Odisha, our transmission, distribution, and that man-made losses, if you cumulate it, it is totally 40%. So if one unit is generated, 40% of it is losses. So if we say 5 units, then we can say that, yeah, we are generating 7 units of electrical energy. And for 5 units of electrical energy, for 7 units of electrical energy, we are saving around 6.8 kg of carbon dioxide emission. And in general, in India, for 1 unit of electrical energy generation, we are carbon dioxide emission is around 0.97 to 1 kg. So here that main motto is to save energy, so that generation we need less amount to generate. Then the next is the from where in Niger how we are getting electrical supply. So basically in any state there is one distribution company and one transmission company. So in Odisha we are purchasing the power directly from the TPCODL, Tata Power Central Odisha Distribution Limited, which is a joint venture between Tata Power and Government of Odisha. TPCOD, it is only a distribution company. So it is TPCODL is purchasing power from the Odisha Power Transmission Corporation Limited. So what TPCODL does, they are purchasing power from OPTCL and they are selling to us. So distribution company is Tata Power and the transmission company is Odisha OPTCL. So from Tata Power, TPCODL, we are getting 33 kV power supply. So the grid, our main grid is near IIT Orgul. It is the OPTCL grid from where we are getting the power supply. So in the next slide, we can show the how we are getting the power supply. So main OPTCL grid is getting power supply from 132 kV. Then in his own substation, they are stepped down that 132 kV to 33 kV. Then that 33 kV through underground cable, which is if you go to IIT Bhubaneswar, that main road, along the road, our 33 kV underground cable has been laid, which is around 6 kilometers. So from there, it is coming to our Niger campus. So if you go from the main gate towards the hilltop, you can see a 6-pole structure there, which is the main entry point of the 33 kV power supply to our campus. Then from that 6-pole structure, then our main receiving station is there inside the Niger. From the main receiving station, we are distributing to different stations. So this is the basically the then what in the main receiving station, what we are doing, we are step down the voltage from 33 kV to 11 kV. So in 11 kV, we have a ring main structure inside the Niger campus. We have different LCS. LCS is called load control station. We have 5 load control station. So that main load control station is the LCS 1, which is nearer to the School of Humanities. So from load control station 1, we are distributing to load control station 2, LCS 3, 4, 5, and another one is the STP. It is our 11 kV distribution structure. So from LCS 1, you can see LCS 1, that 11 kV structure is going to different LCS, and LT line, that is 415 volt supply, it is going to all the academic buildings, School of Chemical Science, Biological Science, and library building, Earth and Planetary Science, School of Physical Science, Mathematics, and School of Humanities and Animal House. Here all the LT supply, that is 415 volt supply from LCS 1 we are distributing. And 11 kV supply is going from LCS 1 to different another load station. So one of the load control station is LCS 2, load control station 2. From here, we are giving power supply to Director and Dean Bungalow, Health Center, Bank and Post Office, Market Complex, E-type residential quarter, and community centers. Similarly, our next LCS is LCS 4. LCS 4 is the main, our main academic building is getting power supply from LCS 4, and main gate, greenhouse, and different hostels, 3-4 hostels they are getting from LCS 4 power supply. And also LCS 5, which is nearer to the football field. From there, we are giving main supply to different hostels and football and tennis court. So this is the main general distribution of the Niger inside the Niger campus. So what is the consumption details? If you go, the way from which we are getting power supply from TPCODL, and as per the contract, we are going under specified public purpose because we are an educational institute. Though we are getting HT supply 33 kV, but we are charged at a less rate than all the industries. because we are not here, not a profit making organization. And our contract demand as per NISER with TPCODL is 2800 kVA. It is the maximum demand. Up to 2800 kVA at any point of time we can take power from the grid. If you take more than that, then we have to give penalty. And if you use less, like in the month of January, we are using only 1860 kVA, but we have to pay minimum 80% of the contract demand, that is 2240. So if you use less than 2240 also, you have to pay minimum 80% of the contract demand. Why they put that clause is that it is in the tariff, it is a fixed rate tariff, because for supplying a load in the grid, they need specific equipments which has a fixed cost, like transformers, transmission line, so that you cannot change at your own will. So you have to, before there is a contract agreement that we will take maximum this much. So in NISER we are taking 2800 is the contract demand. So in the month, in the month of January, we are using 1860 kVA, and it is the fixed cost, monthly fixed cost. And what are the monthly variable cost? Was the number of units generated. So in the month of January, we are consumed around 9,48,000 units of the power. This much units we have consumed, and we have maintained the power factor. In the last slide, we will see why improvement of the power factor is important and how we are improving that. Here we see that power factor is 99.73 we have maintained. So average electrical unit in kVH, it is coming into 9,54,000. So our bill is based on the kVH consumed, not kilowatt hour. If our power factor becomes 1, then our kilowatt hour and kVH becomes equal. So if our power factor is 1, then our units bill will be not 9,54,000, it will be 9,48,000. But it is impossible and very not practical to get the power factor equals to 1 with varying loads. And another one is it is the 50% of the total unit consumption. Like if you take the total unit is 9,50,000, its 15% is billed like 1,43,100 unit is billed in a different rate. So in the next slide we will see. So what are the major components of the electricity billing? First is the 80% of the contract demand. As we have only used 1860 kVA in the month, then we have to pay for 2240 kVA. So for kVA charges is 250 rupees. So it is coming around, the demand charges is 5,60,000. And 15% of the total unit. Total unit is 9,54,000. It's 15%. That is 1,43,000. Because it is inside the NISER, we have both residential and academic complex. So in the same boundary where both the residential and commercial entity is there, they are charging 15% of the total unit consumed at a lesser rate. So, and the rest of the unit, like from 9,54,000 unit, if you deduct 1,43,000 unit, then the rest of the unit, like 8,10,000 unit, we are paying at rupees 5,84,000. So it is 47 lakhs. And one incentive we are getting at TOD. In the previous slide, we have just marked one unit of peak hour unit, kilowatt hour consumed. That means it is the unit where consumed between night 10 PM to morning 6 AM. If you consume the units, what are the amount of units were consumed in during this period, from night 10 to morning 5, we are calling it a off peak hour, because during this period all the electrical utility becomes all the plants, the plants, they are not operational, so the load demand in the grid is less. So to increase the use during the off peak hours, they are giving one incentive. So this is the incentive we are getting 43,000 by using the different for pumping the water, we are running pumps. So we are running these pumps at night so that we can get the benefit. And the next parameter is the electricity duty. Electricity duty is the statutory fee we have to give to the government of Odisha. That is 8% of the total units consumed, like 8% of the A, B, C, and D. So next is the from in the NISER campus, what are the different buildings and their maximum demand? So if you take the total electrical load of academic buildings, all academic buildings means physics, physical science, chemical science, library, mathematics, then it is around 1050 kilowatt. And the main electrical load of HVAC, only HVAC plant is taking around 1060 kilowatt, only HVAC plant. And all the residential building, if you take, it is around 100 kilowatt. And in the summer season, it is going maximum up to 120, 130 kilowatt. And if you sum up all the hostel buildings maximum demand, it is coming around 230 kilowatt. So this is our maximum demand graph. You see between the different years and different months in the same year of the 2021 we have plotted. So maximum we have gone to 2560. So in previously in the it is less, but now it is increasing. And also in the coming year, coming summer also, we are thinking that we can go up to 2600, but it will be less than our contract demand, that is 2800 kVA. So next we another utility area we will take from where water intake well outside the NISER campus. So there is a intake well from where NISER is getting its water supply. Yesterday, Mr. Ramprasad has told about this. So this is some photos I have collected the outside that intake well. So here also we have a power grid, means two-pole structure, electrical supply, and also a DG set in case of the power failure. So if we see the consumption and the electricity bill what we are paying to PCODL, then it is average, that maximum is it is going to 50,000 per month, and minimum it is coming 28,000 per month. So there are some emergency loads in the labs, and also during the power failure, some of the loads need to be run continuously. So to cater the emergency load, we have different diesel generator sets at our site. So if you take the total emergency load is 700 kilowatt. The emergency load includes all in the academic area, some emergency power points are there, which all the labs are using for emergency purpose. And for the academic and for the hostel and residential area, it is only the common utility like lift and passage light, staircase light it is using, and our street light. So to cater the need of emergency load, we have two numbers of 500 kVA DG set, and 5 numbers of 160 kVA DG set, and 1 number of 62 kVA DG set, what we have shown in the intake well. And also for in our pipeline, there are 4 number of DG set which will be commissioned soon. 2 number of 500 kVA, 1 number of 600 kVA, and 1 number of 750 kVA. So operational DG set is total 5 to 7, 8 number of DG set we are operational now. So what is the cost of running these DG sets? So if we run 8 number of DG set which are of different capacity, all total our diesel consumption per hour, it is coming to 50 liters. So if you take 92 rupees per liter of the diesel cost, so it is coming around rupees 22,500 per hour. So in case of power failure in the NISER campus, we are spending 22,000 rupees per hour to cater the emergency load. And in the future, it will increase up to 40,000 because another 4 number of DG set is coming. So it is about emergency load. Then another is the street lighting. So street light we have total load of the 40 kilowatt in the street light. And during the construction, when L&T has handed over the project to NISER, since the last 4 years, we are changing the conventional fixtures, what they are used to LED. So this is the figure. We are just saving 1,30,000 per month by replacing this conventional street light to LED. And if you go in detail, these are the data. Previously, which type of fixtures they are using. Now we have changed to which type of fixture. So in the total, we are saving around 21,600 units per month. So if you monetize it, then it is coming to 1,30,000 per month. So it is just only in the 4 years we have changed it into conventional street lights. So electricity. So now we have around 80% of the street lights is LED and 20% is the conventional street light, which gradually we will change it. So now the load is 40 kilowatt, which is and price of we are spending around 72,000 per month for the street light, considering 10 hours of operations. And there are different street lights like 7 meter, 9 meter. If you come from the main gate and take the right turn, there are two-way road, and in the pole where two sides lights are fixed, it is 9-meter pole, and in the one side light is fixed, it is 7-meter poles. There are 3-meter decorative poles also there, and also high mast. And for our football field and volleyball field and kabaddi court, we have floodlight of 300 watt, which is 80 numbers. So in this way, we are catering the need of street light. And that one main thing in the slides, in the previous slide of energy billing, we have seen that the power factor. So what is the importance of this power factor, we will know here. So as we know that kVA means kilovolt ampere, and power is a multiplication of voltage and current. So V and A, then 10 to the power 3 is kVA, equal to kilowatt divided by cos theta. Kilowatt. Similarly, kilowatt is V and I, and cos theta, this is the unit. This is the power factor. So if the power factor is 1, then kVA equal to kilowatt. If power factor is less than 1, then your kVA will be more than the kilowatt. kVA will be more than the kilowatt. So we are trying to make the power factor close equals to 1, so that our kVA equal to kilowatt. And Tata Power is taking the bill based on the kVA, not on the kilowatt. If our power factor is far less than 1, then our kVA is more than the kilowatt. But our actual consumption is kilowatt. But we are paying more than our actual consumption because our power factor is less. So how we are increasing the power factor? We are increasing power factor through here in the screen. You can see it is a automatic power factor correction equipment. So in every LCS load control station, we have this type of power factor correction equipments. Through this, we are achieving power factor nearly 1, not exactly 1, near to 1. And if you take the data of financial year 2021-22, we are getting incentive of more than 10 lakhs by maintaining the power factor mostly closely equal to 1. So this is one type of energy saving and also cost saving. And then we will see the general ways of energy saving measures. So how we can save the energy, or inside NISER, we are saving energy. And the main is the off-peak hour load. As we have previously discussed, if we run most of the loads during the night time, 10 p.m. to 5 p.m., then the off-peak hour loads unit consumption will be more, and we are getting incentive for that. So if we take the data of last year, like financial year 2021, we are saving around 3 lakhs annually for running the load in these periods. So basically, we are running the water pumps. These pumps are used for taking the water from our water source, which is placed inside the ground level, to our meditation center tank. So that thing we are running at night. So our off-peak hour consumption is increasing. And another way how we are saving energy is in the central AC system, which is in all the academic building where central AC system is used. From there, in one room, there are two types of ventilation. You have means ventilation of air you can see. One is the fresh air, it go inside the room, and that exhaust air, it will come outside the room. So that exhaust air we are taking outside the room, and it is going to a air handling unit room. In every floor, there is a air handling unit room in an academic building. So there what happens, that air handling room, AHU, what AHU is doing, it is filtering the exhaust air which it has taken from the room, and give us and put the temperature and keep its temperature low, and send it back to our room as a fresh air. So instead, if we were not reusing that our exhaust air, what happened? Then we have to use a fresh air. For every time we are using fresh air. So fresh air, the temperature will be more. So our compressor has to take the more load to cool down the temperature. So that way we are saving it. And yeah, and that's similar in your home also. How you can save the energy here? In your split AC system, you have one outdoor unit, one indoor unit. This is the indoor unit, and this is the outdoor unit. So here also, that indoor unit we have a evaporator coil, and the outdoor unit we have a condenser coil. So what does the indoor unit does? It will in the evaporator coil, chilled water is going. So through blower, it is going to our inside the room, and it is collecting the hot air. So if it is not clean, then the cool air cannot 100% go to your room, and the hot air cannot come from that room. So regularly we have to clean that evaporator coil, so that our efficiency will be more. Similarly, in the outdoor unit also, we have to clean the condenser coil. What is the purpose of the condenser? Here, what happens? The hot air coming from the room is going here, and it is being cold here. So if there is dust accumulated in the condenser coil, then the heat cannot be dissipated to the atmosphere. So there is a pressure on the compressor, and compressor will run more. If the compressor will run more, then it will take large amount of electrical energy. So one way in every household we can save the energy is that we have to periodically clean the indoor unit evaporating coil and the outdoor unit coil. In this way, we can save a considerable amount of energy. And next is the energy saving measures, like in our HVAC system, that chilled water is going from our HVAC plant to all the academic building through insulated pipelines. So we are ensuring that that pipeline insulation should be intact, so that no heat loss during the transportation is there. So in this way, we are saving so that if there is a temperature loss, then our chiller unit compressor there will be more pressure on the chiller unit compressor, then electricity consumption will be more. And one thing, we are using the street lights. There we are using timer. So we are fixing the timer, like evening 5:30 it will switch on, in the morning 5 o'clock it will switch off. So it will automatically switch on and switch off. So there is no manual intervention. So the chances that some street lights are on, some street lights are off, it is eliminated. And another thing what we can use is now there is one type of technology, brushless DC motor fans are now readily available in the market. So in place of conventional fans, we can use the BLDC fans. The conventional fans, it is consuming around 70 to 75 watt power, but that BLDC fan with the same cooling capacity, it is consuming less than half of that, around 30 watt. So in this way, we can, in the individual household also, we can save the energy. And at the last, I will show you some of the waste and we have accumulated. So this is actually the choke unit. So previously in the conventional LED light fixtures, we are using a tube light where we are using starter and choke for that. And now what we are doing it, we are replacing it to LEDs. So if we are putting LEDs, then there is no need of starter and the choke. So these chokes are either faulty or we are changing it for our converting to our LED. And similarly, these are the aluminum housing fixtures of old or conventional lights which we have changed. And these are also things. And these are, as Amarendra sir was told, that these are actually not waste. We can, because this choke, if we can sell it outside or recycle it, it is basically a metal frame, and inside it, copper coils are there. So we can monetize it by selling. Similarly, these are the aluminum, and these are also aluminum. And also these waste we have collected, and through proper committee or proper scrap committee, we will sell it to the vendor and monetize it. Okay, thank you. If you have any doubt, you can.
It's a very nice presentation, Amit, and it is also a detailed presentation. But Amit, I have one question. Compared to the last 4 to 5 years, the electricity what we have consumed is around, what we are paying is around 54 lakhs. But
Yes.
now we are paying around 64 lakh. What is the reason behind that we are increasing every year by 3 lakhs more?
Only, sir, is the units. Only is the number of units means increasing the number of units only. So, and also in the recent we have increase in the per unit price. Previously 5 rupees 90, sorry, 4 rupees 80 paisa we are paying. Now we are paying 5 rupees 92 paisa.
Oh, that is the only reason.
And also this time also they are planning to increase the per unit price more.
Acha, Amit, I have one more question. As you said, we are using around 600 split ACs.
Yes.
So, what is the use of if you use split AC instead of the central AC? You are saying central AC is consuming 1060 kilowatt unit kVH.
Yes.
So if we use split AC, it will be less or it will be more?
No, if you individual that total tonnage of the cooling requirement, if you compare, then individual AC is costing more. Total central AC is economical, but here what happens, due to some water scarcity problem, during last 2 years we cannot able to run the central AC. So the labs which need AC barely, they have go for the arrangement of split AC. So now it is redundant. So what we can do is, if we are seeing that yes, central AC is working, we can manually switch off the split AC, so that in our lab energy can be saved.
But in the summer season, we have noticed that the central AC is only operating the air part, not the chiller part. So
no, that the problem is due to that like scarcity of water.
Right,
but,
right. That I understand. But in that case, both the consumption are same if the blower is running and the chiller is not
no,
running.
No, in that case, the consumption is around 40%, because that chiller unit, that compressor is taking more power than and that it is just a blower. So it is around 40%.
Okay, okay. And anybody else want to ask any question to Amit?
Sir, I have
please unmute. Ramprasad, please unmute.
Yeah, it's unmute. Is it audible, sir?
Yeah, yes, tell me.
So, as you told, sir, this BLDC fans.
Yes.
So is there any plan to change our now all everywhere conventional fans only fitted?
No, actually means we have done it for the LED, means conventional light fixture. We have changed to LEDs because also all the fans that are put by the L&T is very new, so there is no problem is coming. So now means changing to BLDC is not economically viable. But if you take for street lights, why you have done is that then there is a monitoring committee from the government of India, which forces us to change to LEDs from conventional street lights. So we are doing it, and also in the future, in the next build, like mathematics building extension is coming. There we are using all BLDC motors. Sorry, fans.
So is there any price difference between this BLDC fan and normal fans?
Now, sir, the price of BLDC motor is little high. Like if you go for a normal conventional fan, it is coming around 2,000 to 2,500. If you go for a very good energy saving fan, but if you go for BLDC, it will be around 3,400. But in the long run, it will benefit because it is 50% of your energy consumption.
Yes.
And fan is the only apparatus you are running for a long time in your home, because light at the night you switch off, but fan is running continuously in the day and time. Night, sorry.
So there is a hope in future it may replace, I think, which this conventional fans when it will go back or damage.
Yes. Already CPWD has already has given its all technical data. And from the next time onwards, when you can, as we are depending on the CPW specification for tendering, we have already got the technical data for BLDC fans, so we can go for that.
Okay. And one more, sir, this from IIT, our main grid is coming, means power is coming. So yes. I think I remember 3 years back or 4 years back, means there is some due to dig in our Reliance or someone. So for 4 days power is off, you know better.
Yes.
So if there is any signboard in place, the means cable, high tension cable is inside. So no one will means that is anyhow it is 2 meter or 3 meter
depth. No,
So
actually initially all the cable markers were there, but as it is coming, as it is a common area, then different construction works after our cable laid, there are different construction works going by the state government and some private agency. So in the meantime, all the markings has been gone. So, and another one is that around 1.5 meter depth our cable is there. And at that time, why it was damaged is that another underground cable, which is supposed to give power supply to Jatni. So that cable is crossed during that time. So there was a fault in our cable, which creates a lot of problem. And for that also, we are planning now. We are planning to get one overhead line from the Jatni grid. So if there is a problem in the underground cable, we can take the power supply from the overhead line. And overhead line, the underground line also a lot of benefit as compared to overhead lines. Like in the cyclone Fani, everywhere supply is not there, but because of our underground cable, we are getting supply in the next day. So we are planning to have both underground and overhead supply.
Oh, thank you.
Any questions from student side? Any questions from student side? Ajay Babu, Ajay Das?
Yeah, I have one.
Yeah, please unmute and ask.
Okay. So in the future, are we going to change our power supply to renewable energy sources like solar energy or something like that for the street lights or?
Yes, sir. Actually, means one DPR has been prepared. It is by one of the Rajasthan electricity, Rajasthan renewable energy, it is a public sector undertaking. So that there are two modes of operation for the renewable energy. One is capex, one is opex. So capex, in the capex model, all the cost we have to bear. So it will be a huge cost. So we are planning for opex model. So in the opex model, all the fixed cost, all the major cost will be borne by the agency, and we will purchase power from them at a rate specified by Government of India, which is around 2 rupees or 1.8 rupees per unit. So that proposal is under consideration by directors.
Okay, thanks.
Any questions from student side? Any questions from student side? No. So Amit, it was a nice presentation. So thanks to
Thank you,
you.
sir.
Thank you. Thank you very much.
Okay, thank you, sir.